This is Akashvani Chennai. We bring to you an interview titled IMD, the Pulse of India's Weather. Participating in the interview is Dr. B. Geetha, Scientist, Regional Meteorological Department, Chennai. The Indian Meteorological Department is a vital institution dedicated to providing accurate and timely weather forecasts, warnings, and advisories to the people not just in India, but also surrounding nations. As a key component, the Indian Meteorological Department plays a crucial role in safeguarding lives, property, and economy from the impacts of extreme weather events. With its state-of-the-art infrastructure and expertise, the department is committed to delivering reliable and actionable weather information, thereby contributing to the socio-economic development and resilience. Its tireless efforts underscore its commitment to serving the community. Such a pleasure to welcome you to our studios.
My pleasure too to be a part of your program.
Thank you. Ma'am, what are the current weather trends that we are having in our region, and how are we expected or how are they expected to change in the coming months?
Presently, southwest monsoon withdrew from the entire country on 16th October, and simultaneously the northeast monsoon rains commenced over Tamil Nadu, Puducherry, Karaikal, South Andhra Pradesh, Kerala and South Interior Karnataka. During this changeover, the direction of winds underwent a reversal from westerlies to easterlies. That is now, as we are aware, over the tropical region, surface level winds always blow from the east. That is now your northeasterly trade winds, you may be aware of that.
Okay.
Likewise, the southern hemisphere, it is southeasterly trade winds. So generally the surface winds are easterlies. But during the southwest monsoon season, winds blow from the west. And then when the monsoon withdraws, the wind direction changes and reverses back to easterlies. Once the reversal happens, then the rainfall picks up over Tamil Nadu. Because before that, during the southwest monsoon season, Tamil Nadu is in the rain shadow region of the Western Ghats.
Right.
It does not receive much rain during that season. Actually, the chief rainy season for Tamil Nadu is the northeast monsoon season.
Okay.
After the southwest monsoon withdraws and the easterlies reverses back, rainfall picks up more over our region. So that is the chief rainy season for us. October to December is the period. And during this period, about 48% of our annual rainfall is received. All the agricultural and hydrological activities of Tamil Nadu, Puducherry and Karaikal are all planned according to this northeast monsoon rainfall. Also, incidentally, this northeast monsoon season is the chief cyclone season for the North Indian Ocean. So aside from the northeast monsoon rainfall, the cyclones forming over the tropical cyclones also affect our
Weather patterns,
region. So they also actually cause extensive damages due to torrential rains, gale winds and storm surge, and they also modulate the northeast monsoon rainfall activity.
Okay, how does the IMD, that is the Indian Meteorological Department, monitor and predict the weather patterns, ma'am? And what are all the tools and technologies that we use?
See, India Met Department maintains observatories with the state-of-the-art instruments calibrated as per the standards defined by the World Meteorological Organizations. That is, all national meteorological and hydrological services, they are all coming under a single umbrella under the World Meteorological Organization. And the World Meteorological Organization has stipulated certain criteria to be followed regarding maintenance of observatories, where it should be kept, and what is the exposure condition, what are the standards for calibration. All the countries which are all under this WMO, they follow that.
Right.
We are also following the standards prescribed by the World Meteorological Organization. And so we take on record observations as per the time stipulated by the World Meteorological Organization. At the surface level, observations are taken at every 3-hour intervals, starting from 5:30 IST, 5:30, 8:30, 11:30, like that it goes. And in upper atmosphere also we take observations for up to say 15 to 20 kilometers from the surface. These observations are taken 2 to 4 times a day, depending on the availability of all the instruments and other parameters. And all these observations, plus over the ocean, ships are also having meteorological instruments. They also take observations and voluntarily share the data with us. Voluntary observing fleet, we call them.
Okay, that's done separately.
Whatever ship is flying over the ocean, when they will share with us. Because our observatories are all over land. So how are we going to take observations over the ocean? Because ocean is a very part of our forecasting area, isn't it? So voluntary observing ships. And also in Chennai itself, we have a National Institute of Ocean Technology, NIOT.
Right.
They deploy instruments, what is data buoys, moved to the ocean. So they will be floating in the ocean and they will take record observations and transmit. So these observations are the basis for the ocean. In addition to us, umpteen number of products based on satellite observations are available. Indian satellites continuously monitor over the Indian region and give us a wealth of information. And then there are also other foreign satellites which revolve pole to pole. And then when we call them polar orbiting satellites. They will not be seeing over the same area. As the Earth rotates, different parts of the Earth will come under their view. So they will be seeing different parts of the Earth. But if you have a constellation of satellites are used so that the entire globe is monitored at any instant of time. So you will get an observation at all instants of time based on satellites over the entire globe. All these observations are used, and radars, coastal radars are very important. Many of us will be knowing how radars are important, especially during cyclone period. They are seeing the ocean and giving us wealth of information. So these are all our monitoring tools we use. And then for forecast, and we are also now expanding our automatic weather stations and rain gauge stations to increase the density of observations. And then these data are used by the international centers running numerical weather prediction, because all these data, radar or satellite, whatever it is, they are going to give you the observation at any instant of time. If we are taking observation now, it will give you the state of the atmosphere at this instant of time. But what you want is what is going to be the state after few hours, after 1 day later, 2 days later. So there only the science comes in. So our understanding of the science, to the extent whatever we have understood, we have all put in the form of mathematical equations. And then the computers are used to solve them. Numerical solutions are given and the computers are used to solve them. That's why numerical weather prediction centers are internationally, we are having very important centers. They all use high performance computers, supercomputers, to run these models, because to solve these equations and to calculate the parameters at different instants of time at different locations for the entire globe, you need such massive computing facilities. So supercomputers are used. And then the observations that we take, they only define the initial conditions for the model. So at time t equal to 0, this is the observation. But at time t equal to 12 hours, 0 plus 12, 0 plus 24, computer will now calculate based on the science we have given into the computer in the form of models. And then it is going to calculate and give you the future state of the atmosphere. So for that, a lot of research has gone in. But then not that everything that is happening in the atmosphere is understood fully. We are in the evolving phase. That we have, this science is like that. It is, we are in the evolving stage. Whatever has been understood so far, that we are trying to use to give a prediction. And always there are challenges, because topography. The topography is an important parameter for forecasting. The topography itself is changing. So the science is still in the evolving stage only. And then if you see all the products that satellite-based, radar-based, numerical models, observations, all of them, we have a decision support system. All these products can be seen, overlaid and seen and analyzed. So forecasters use the decision support system to analyze all these things. And then every day there is a video conferencing of all forecasters all over India. So every day in the morning we sit for 1 hour, see what are the important weather parameters that need to be, what are the weather systems that are available, see important features that we note, what kind of weather we can expect over different areas. And then we will propose our forecast, what we are planning to give. If somebody suggests some other thing also, we will take into account, because
it's
all
like
of us
a
are
wholesome teamwork.
Yes, it's a pakka teamwork only, the forecasting is. Then after that only final forecast is finalized and given. And observations are taken at different locations. How are we going to use it for forecasting? See, we have observatories at Pamban. We have one observatory, Adirampatnam, Tondi, Kadalur, Puducherry. So every 3 hours they are taking observations. Those observations need to go to the forecasting centers, then only it can be used. So internationally there is a facility prepared by the World Meteorological Organization known as Global Telecommunication System. So in that, all national meteorological agencies are hooked into that. So all the observers taking observations in Sri Lanka or Thailand or Malaysia, all those people, they will put the data in a proper WMO specified coded format. Everybody will use the same coded format. So all of us will put the data into that. And then it is shared. So data exchange. For that, actually, IMD is one of the regional telecom hub. In New Delhi, we are having contacts with Washington, so for international exchange. And for South Asian exchange, this is the hub. So this kind of facilities have been made by WMO for data sharing. All these are not networking. Everything is actually in international collaboration only it is. That's why data taken at, say, Thailand, we can see after 10 minutes here. Our observer in Kanyakumari, whatever observation he takes, any person in Africa can see. But the people who are in this under this WMO facility, they can see this data. So that's why all modeling centers take these observations to define the initial conditions of the atmosphere and then run the model and give the future state. So that is about the technology and the networking that is required. And then all the instruments are all state-of-the-art instruments, because you know that science need to be improved, and for that instruments and observations are the key. So whenever a new technology comes, any advanced technology comes, we always update, and then try to expand our observing networks also. So for we generally issue forecasts and warnings for about 7 days and update it daily. And also 3-hourly nowcasts also we give, to give any severe developments, of sudden developments are there, we cover in the nowcasts. Separate tailor-made bulletins are issued for farmers, fishermen, marine communities, for the coastal and the sea areas. What will be the weather, that kind of sea condition, all these things. And meteorological services are also rendered to the aviation sectors. And for dissemination of all these warnings and bulletins, we use standard like email, website, social media updates, SMS, WhatsApp. And during severe weather period, civil authorities are also briefed telephonically as frequently as possible. And the public are kept informed by frequent updates in our websites, and also through the media, press and the electronic media. They do a great service like All India Radio. You take a lot of time to broadcast this thing.
Yeah, we have a dedicated time.
Yes. So the public are kept informed.
Now, ma'am, what are the most common natural disasters that we face in our region, and how do we prepare for them?
Most common natural disasters for our areas means mainly tropical cyclones and heavy rainfall causing flash floods and riverine flooding. Recurrent heavy rainfall leading to mudslides and landslides, especially during the monsoon seasons. And hot and humid weather and heat waves during summer season. And of course, sometimes earthquakes. These are the major natural disasters in our region.
Okay. So how do we prepare for them?
To mitigate these disasters, preparatory actions are taken at different levels by various stakeholders. Early warning is a major component to prepare, and that we do our best for that. And then, parallelly, the state indulges in a set of preparatory actions to mitigate the impending danger. Preparation by the state and local communities to reduce risks during natural disasters, like, say, evacuating vulnerable people along the coast to safer shelters during cyclone periods, being prepared to reach inundated areas through boats, NDRF, they are all kept ready for that. Right. And then community kitchen facilities are prepared for the people who are moved to the shelters. And then medical camps are set up for the people who are outside and then who need medical emergencies. And national and state disaster response forces are kept in readiness to act at any instant of time. And for the people to be kept informed, always our media, they are the pillars. Always keep the people informed what is the current status and what is to be done, what is the best advice given by the government. So these are all the preparatory actions.
We have special cyclone bulletins that are also
issued.
Right?
Yes.
Tracing the entire movement of the storm and other things.
Yes. That's what I was telling you. Normally we issue bulletin a day and update it in the evening. But as depression or deep depression forms means 4 to 5 times updates will be there. Cyclone means 8 times update will be there. So every time any changes there, we can always inform the public. And on the day of landfall, hourly updates we'll give. Every hour we will send the updates.
True. Now, how accurate are IMD's weather forecasts, and what measures are taken towards improving accuracy, ma'am?
See, as I was telling you earlier, this science is not fully understood science. Right. Okay. We are in the evolving stage. But we can safely say we are comparable with the international standards. The meteorological science is growing, and especially for our tropical region, the science is too complicated. The atmospheric processes, interactions with oceans and land are not fully understood. And so there is no clear-cut single solution for any meteorological problem. More so, as I told, in the tropical region, wherein local developments bring in more complexity and chaos. That is why more and more models are developed and more observations are added to better define the initial conditions. And then technology advances, whatever comes in, we are taking. If you may be knowing, first time when the radars were used during war period, Second World War. Okay. After that, the first civil application of radars came for meteorological science. Okay. So those radars were left after the war. Okay. So our people started taking that radar and seeing the clouds. Technology advance comes, we are ready to use, so because we want it, anything, because we want to improve. Right. There's a lot of grey areas we need to understand better. So any equipment which is going to throw some extra light, we will always use it.
So what role does the climate change, now we already discussed as a point, but what role does the climate change play in shaping our region's weather patterns, ma'am?
See, you may be aware that global average temperature is increasing every year, and more cyclones are becoming severe cyclones. That is what the probability of a cyclone becoming severe cyclone is increasing. And then short duration intense rain spells are increasing. You may be experiencing that also. We are here in Chennai, we experience this nowadays. Very short area, short duration, intense rain spells. And more heat waves are also observed during summer season. So these are all due to the climate change, urbanization, more of carbon dioxide release. No, all these things contribute a lot to this. What to say?
The weather
Some
patterns,
weather
yeah.
patterns.
Okay. So, how does the IMD collaborate with other agencies and other organizations, especially to disseminate with the weather information, ma'am?
So IMD's work itself is a collaboration. Actually, we have our sister institutions, Indian Institute of Tropical Meteorology, who is engaged in full-time research and numerical modeling.
Okay.
And they are doing for an extended scale. And then National Center for Medium Range Weather Forecasting, that's in NCMRWF, it is in Noida. They are doing numerical modeling for medium range. And then INCOIS, that is Indian National Center for Ocean Information Services in Hyderabad. And I was telling you NIOT in Chennai. All these people, we are always in collaboration with them because NIOT is deploying buoys and their data we are using. IITM, NCMA developer are running models, their outputs we are using. And likewise, INCOIS is giving a lot of information about the ocean that also we are using for our fishermen warnings. So it's a collaborative work only what we are doing. And aside from that, we have frequent interactions with the state disaster management authorities, especially during severe weather periods for disaster management aspect. And sector-specific bulletins are issued. For this agricultural sector, separate bulletin, not the normal bulletin that we send to IAR. So agricultural sector will have separate different parameters, humidity, wind speed, wind direction, different parameters, whatever they require. So that's a tailor-made products are prepared for agriculture sector, fishing communities, marine communities. For marine communities, they will want the wind visibility, wind direction, whatever is required for them, sea condition. So they will be given that kind of information. And then the aviation sector. Any pilot, if he takes off from a place from here and lands, say in London, then he will want to know the weather over Chennai, weather over London, and weather en route weather. So this kind of information he has to take. So according to the requirement of the person, information will be
It's like
shared.
personalized to a
Yes,
sector.
it's customized for them.
Yeah.
So that kind of informations are shared. And Department of Telecommunication, they have developed an integrated alert system which we are using. So if we post our warnings in that, then the state disaster management authorities, they will use it to disseminate the warnings to the public.
Yeah, we keep receiving SMS during
yes,
cyclones.
Yes. So multiple institutions are involved in this disaster management.
Okay. Okay, ma'am. So what are the plans of IMD for upgrading its infrastructure and technology towards forecasting?
So you may be aware that recently government also announced on Mission Mausam one project is taken. So the goal of this project is to make the country, that is our Bharat, a weather ready and climate smart nation. So that we can mitigate the impact of climate change, extreme weather events, and strengthen the resilience of our communities. So the objectives is to develop cutting edge weather surveillance technologies and systems, implement high resolution atmospheric observations with better temporal and spatial sampling and coverage, implement next generation radars, satellites and with advanced instrument payloads, implement more high performance computers, improve understanding of weather and climate processes and prediction capabilities through research, develop improved earth system models and data driven methods using artificial intelligence and machine learning, develop technologies for weather management. That is a very, very interesting area, weather management.
Okay. Lot of scope for research as well.
Research, then it also brings in weather modifications. Supposing an airport is fully with snow for some time, there are technologies to disperse that.
Okay.
So we have to go to that. We cannot wait for that to disperse on its own.
Okay.
The weather modification is another area we have to work on. And develop state-of-the-art dissemination system for last mile connectivity. And then, of course, enhance our capabilities. These are all part of the objectives of this Mission Mausam. So this, if when implemented, it will be definitely a booster for our improvement. Yes.
Okay.
Our services.
Yes. So how does the department engage with the local communities to raise awareness about weather related issues, ma'am?
We interact with the public, and public generally, even for a drizzle, they will call us. Round the clock, our control room is there. They will call us and ask whether it will rain today. Now it is cloudy. So they will give us a lot of information. And we also frequently hold stakeholders meet. So in those stakeholders, we have a one-to-one interaction with them, where we'll ask them whether our bulletins are useful. Of course, we know it is not 100% perfect. We are not going to claim that. But then whether it is of any use, and whether they have any whether if they have any ideas that can improve our inputs to them, We will take their inputs and accordingly prepare our bulletins in the
Okay.
future.
So it's like a two-way process.
Yes. Take their feedback and then improve on yourself or your work.
Okay. So how does the department monitor and predict the air quality in the region, ma'am? This happens especially during the winter.
Yes.
Look forward for the smog and other things.
Here we not much, but in the north it's a big, especially Delhi. So IMD actually uses two types of models. One is called the SILAM model, that is Systems for Integrated Modeling of Atmospheric Composition. And also another model is there, System for Air Quality Forecasting and Research. So this provides real-time data for 1 to 3 day forecasts for major pollutants. And it is right now, it includes a network of monitoring stations in Delhi, Pune, Mumbai, Ahmedabad. But it has to expand.
Okay.
And then it is having a separate air quality early warning system for National Capital Region. It provides high-resolution forecasts to help authorities implement action plans to moderate air quality levels. And we are also planning to establish a network of air quality monitoring stations equipped with automatic weather stations to monitor and provide air pollutant information and weather round the clock. Now the plan is for Delhi, then it will be slowly expanded to other places.
So do you collaborate with the international organizations? You told us about the various things laid down by the WMO. So what are the international organizations you collaborate with?
WMO is the major one. They facilitate our interactions, and actually even data sharing. See, we have our data sharing, they are given as a platform. So these data are used by various numerical model running. European Center for Weather Forecasting, they take our data for running global model. See, a global model needs global data. But who is going to take observations for the entire globe? Every person will take for their region and they will share it. So all, whether it is US or Europe or Japan, if they run global, and IMD also runs global models. But we don't take observations over New York or Washington. So we take their observations. So the observations are taken at different places. They are all shared through this WMO platform. So this is a very important collaborative work it is, running models, taking data sharing, and then even the forecast products. All the products that we generate, many important products are shared openly in the website for people to use. Many people who are all interested in weather, they see all the products and they also parallelly give. Because these products are shared free of cost through the website. So that is also being used. And then we also have regional specialized meteorological centers covering the entire globe, especially the tropical region, especially for tropical cyclones. So for our South Asian region, New Delhi is the RSMC, Regional Specialized Meteorological Center. So we will now try to help our neighboring countries also for during cyclone periods. So if some country does not have radars or some facilities, if we are able to see something, we will issue advisories to all the national meteorological agencies. So they can use this as inputs for their forecasting.
Oh, that's very nice. That was very enlightening and really educative, ma'am. Thank you so much for sharing all your inputs with us.
Thank you very much, madam. Very fine, and thank you.
Titled IMD, The Pulse of India's Weather. You heard to Dr. B. Geetha, Scientist, Regional Meteorological Department, Chennai. She was interviewed by me, Rajarajeshwari. This program came to you from the studios of Akashvani, Chennai.